Hi everyone, this video is going to be really useful and informative because I'm going to explain full piping course in this video. Whatever the background you have, either you are in design, engineering, operation, maintenance, inspection or project management, this video is going to be really useful if you want to know about piping. It could be you are interested a little bit about piping or you want to go in details. This video should be really helpful and I am confident this video will be one of the best videos you have ever watched about piping. And this course in this video will be about 1 hour long video, and if you are ready, let's start. Just briefly about my introduction. My name is Abdul Jabbar and I have engineering background with over about 20 years of experience in different industries, mainly in hydrocarbon, petrochemical, and process industries. I have performed multiple roles and mainly my role was around piping engineering. Alright, without further ado, let's start piping design complete course. Broadly, I have divided this piping course into 3 categories. First one is a piping design and layout, and second is a piping stress analysis, third is a piping materials. I will explain all these 3 categories first briefly, then I will explain all these 3 categories with the help of a practical sample design of a plant piping. Let's first see what will be the content in this course. So the contents of this course will be, I will talk about first what is piping, its definition, then what is piping design and layout, piping stress analysis, and then piping materials, as I just briefly mentioned in my last slide. Then afterward I will use a practical example and explain all the bits of piping system like piping equipment, pipe and line pipe, pipe fittings, and pipe flanges. This practical example will show how to use manual valve, control valves, strainer, and expansion joints. I will also explain about instruments, pipe supports, and piping asset integrity. So you can see there are 15 contents in this course. One more, there is a timeline of all these contents in the description of a video, so you can also go there and watch any content whichever you like most, or if you want to go back and watch again that particular content, you can easily go there. So all the timeline of this course is listed in this video's description. Have a look at the description of this video. If you have any question, query or feedback about this video about piping course, and here is a contact details. You can follow me on my LinkedIn page. The address is a EKT Engineering Consultants. You can also approach me via WhatsApp, only SMS, please no call. Also not necessarily about piping, but you can ask any question about other engineering disciplines as well, and even about job career. I will try to guide you as much as possible. Thirdly, if you want, you can also subscribe this YouTube channel. This channel will be one-stop shop and to get all the relevant knowledge, answer of your question, tips, and about piping engineering and other disciplines as well. Also things I will try to share based on my experience, knowledge, and best industry practices. You can comment, like this video. I will try to upload 1 or 2 videos in a week, not necessarily about piping, but could be other engineering disciplines as well. Right, so first let's talk about what is piping. There are many definitions of piping, but to cover all, piping includes pipe, flanges, fittings, bolting, valves, and pressure containing equipment could be special piping item. It also includes pipe sports and other items to prevent like overpressurizing and overstressing. Pipe sections, when joined with fittings, flanges, valves, and other mechanical equipment and properly supported, they are called piping system. A safe, reliable, and economical piping system needs a good design engineering. It also needs fabrication, inspection, testing, commissioning, maintenance, and even operation. Now, let's first talk about what is a piping design and layout. It takes a lot of consideration, experience, knowledge, implementation of knowledge, experience, and best industry practices to produce safe, economical, and reliable piping system. I will talk about some typical aspects which need to cover to make this happen. First of all, to design any piping and layout particular, first of all, we need to decide what is a piping code, which should follow local and client needs and their expectations. For example, ASME B 31.3 process piping code, which is most commonly used code for piping. There could be other piping codes like B 31.1 for power piping, and for pipelines we use B 31.4 or B 31.8, or could be other as well, depending on which area, location, or country that piping or pipeline project is going on. Then we need to think about a general plant conditions like environmental conditions, plant design expected life, and what language we will use in design and drawings which will produce under piping design system. Then comes to understanding design parameters for piping system. These may include but not limited like design conditions, operating conditions, pressure, temperature, stress criteria, piping materials, quality assurance, hazardous substances, insulation, drain, and venting and isolation requirements. There are other aspects as well which we need to consider for a good piping design. They are like line sizing. It will involve pipe size, corrosion allowance, erosion allowance, depending on the type of the service inside the piping system, line velocities, piping layout. It will general layout requirements will be including like piping flexibilities, piping spacing, accessibilities for maintenance, inspection, operation, flange connections, and other connection details like pipe branches, and it could be like underground piping, pipe racks, pipe sports. So we need to think about all these aspects, and other aspects which we need to consider as well are construction point of view, procurement point of views, fabrication, NDE, inspection, testing, and commissioning as well. One more thing, I have made a full video about FEED, which is a front end engineering and design. If you are interested, you can go there and have a look, and link of this video is coming to top right side of this video. You can click this, or otherwise you can go to this channel and there is a FEED video which is going really popular, and there is a lot of useful information about FEED there. Right, now let's talk about briefly piping stress analysis. Whatever piping code we will use, it could be B31.1, 31.3, or any other code. It is a code requirement to make sure whatever piping design we will do, or we do the layouting, the stresses produced in the system should be within the allowable of the code values. It's hard to cover full piping stress analysis details in a few slides, but I will try to cover the main highlights at least. I will talk about first what are the stress analysis objectives, inputs for stress analysis, and what are the outputs for stress analysis. In this slide, I will talk about what are the objectives of piping stress analysis. Stress analysis is required to make sure, as I said earlier, to make sure all pipe and its component are within the allowable stress range used under different stress categories. And these stress categories are sustained or gravity, pressure, thermal, occasional, and hydro test category. For piping connected with equipment does not put more load than the nozzle allowable of that equipment. Also, we need to make sure that pipe supports and the load on those supports, and we also need to look after the dynamic potential problems. We need to check the pipe displacements. These are the main objectives to perform stress analysis. And now in the next slide, I will talk about what are the typical inputs to perform piping stress analysis. Right. Let's talk about what are the typical inputs for piping stress analysis. The two main softwares which we use commonly in industry for stress analysis are Caesar and Autopilot. The main inputs required for stress analysis are like, we need to know about pipe size, pipe thickness, schedule. We need to know about pipe material, fluid properties like temperature, pressure, gravity, what is the corrosion allowance, and insulation type, insulation thickness. We need to know what is the friction coefficient, equipment drawings, wind and seismic coefficients. So these are the typical inputs needed to perform a stress analysis. Again, this is just briefly, and in next slide I will talk about what are the typical outputs of piping stress analysis. Alright, now let's talk about what are the typical outputs of piping stress analysis. The main piping outputs are like, to make sure the piping system which we design is a code compliant, support loads for civil and structural design, piping layout geometry finalization. We will make sure that loads, piping loads on the nozzles are within the allowable nozzle loads of the equipment, and spring hanger data sheets, support type and location we do confirm after piping stress analysis. Right. Before going further, so just to summarize whatever we have gone through, we talk about what is the piping, we talk about what is a typical piping design and layout, we talk about piping stress analysis so far. Before going further, just want to share with you, which I think is also a great, helpful, and maybe a bonus tip for you. I have written a book which has more than 200 questions with answers. These answers are based on code, standards, and best industry practices. I'm super confident this book will improve a lot of your knowledge about piping, because this is a practical questions, problems, and their solution which I have observed over the period of my experience, and all the content which I've shared on LinkedIn or whatever I learned through performing a different type of projects. This is a great way to understand about piping, as the answers are based on practical experience, knowledge, code, standards, and best practice, rather than long theories just here. These questions cover all aspects of piping, like design, material, stress analysis, code fundamentals, and these questions can be used to prepare your next interview for a job as well. And if you are interested to get your copy, get in touch with me and to know more, and I will share the details from where you can get this book. All right, now let's talk about piping material. Let's talk about piping material for any project or piping. Basically, any material of piping system is based on material selection criteria, which we will make sure that that criteria meets the project requirements. Also, we need to make sure selected material meets the governing piping code, because every code has their own approved materials. It's hard to cover again full piping material details in next few slides, but I will try to cover the main highlights. Like as an example of pipe, we need to understand what is the type of pipe needed for the job. It could be metallic, non-metallic, galvanized, FRP, HDPE, stainless steel. Also, we need to do mention what will be the pipe size, what will be the schedule, thickness, and for fitting standards, like we need to mention SB B16.9, B16.11. What is the required material, metallic or non-metallic? How about branches, T's, elbows, and other fittings? For flanges, we need to mention the required materials, sizes, flange rating, flange facing, and connection requirements. For bolting, what are the requirements of stud and bolt, and bolt lengths, required threads, and also how about for gaskets? Is metallic, non-metal, flat, spiral, raised, and other manufacturing requirements. For valves also, we need to mention what will be the standard code, type of valves, requirement, including operation hand wheel, actuator do we need, and what are the details about valve body, seat, testing requirements, then installation requirements as well, requirement for special piping items if we use, and also there could be special piping items like whenever startup of any new plant or after shutdown, we need like startup strainers, temporary equipment, so we need to mention details about them as well. We also need to mention design, fabrication, welding, heat treatment, examination, inspection, and testing standards as well. So basically we need to provide details, enough details of all these items as a minimum for any project material requirements. Alright, so far we have covered as an overview about the all three aspects of piping: piping design, layout, stress analysis, and piping material. Now I will explain all whatever so far we have gone through or learned through a sample design case of piping. So it should cover a lot of aspects, and it should give a good explanation, and it should answer a lot of your questions. First thing first, let's talk about and understand quickly any plant, refinery, or processing facilities. There are range of equipments we can see in that facility. These equipments could be like pumps, pressure vessels, heat exchangers, columns, compressors, cooling towers, storage tanks, etc. And all these equipments are connected with each other through piping. Here piping role starts. From piping point of view, we have interface with equipments. Like we need to know about their geometry, their orientation, nozzle locations, nozzle allowable loads, nozzle stressing details. All this information about pipe equipments we need to know, because we will connect different equipments, and here is the piping comes. Alright, so for this video, to understand about piping, I have taken as an example of tanks area. I will explain all piping aspects using this example. Let's assume there are 3 tanks. These tanks have fluid inside, and now we need to transport fluid from one tank to another. 2 tanks are vertical and 1 tank is a horizontal. I will keep referring this example again and again throughout my video to explain different concepts of piping. So hopefully this will be helpful for you. Now let's first talk about pipe or line pipe. First, for each equipment component, whatever I will use an example, first I will try to explain briefly, and then I will use that particular component of piping system in the example. Okay, so first thing first, we will talk about what is a pipe, what is a line pipe, what are the important details we should know. There are many definitions of pipe, but simple one is it's a tubular item made of material including metal, plastic, meant for transporting liquid, gas, or anything that flows. It comes with different sizes, thickness, and quality. There are different standards of its manufacturing, but most common material for pipe is a ASTM A106 grade B for piping, and if it's a pipeline, the most common material is a API 5L. If you want to know more about pipes, I have made a separate video about pipe as well. You can have a look this, and a link is coming on top right side of this video. Now let's bring back our example. We got 3 tanks. In order to transfer fluid from one tank to other, we need to connect them, so we will use pipes. Alright, here we have installed pipes. You can see there are still some holes and free ends of pipes. These free ends will be fixed by pipe fittings. In next slides, I will talk about how to address them as well. Alright, before going further, let's talk briefly about pipe fittings. Fittings are used in piping systems to connect straight sections of pipe or tube. They have different sizes and shapes. There are different types of fittings like elbows, T's, reducer, unions, coupling, crosses, plugs as well. They are made of different materials like could be carbon steel, stainless steel, FRP. They have ASME and ASTM and other standards of its manufacturing. So that was a brief introduction about pipe fittings. Now let's use pipe fittings in our example and see how our piping look like now. We will use here 90-degree elbow, equal T, and reducer. So you can see we have successfully installed pipe fittings and our piping system is in a bit of shape now. If we can see here, pipes are successfully connected, but in next step we need to connect pipe ends with tank nozzles. These points we call terminal connections, and we will use flanges and welding to connect pipe ends with the nozzles of tanks. At this stage, pipe ends are not connected with the nozzles of tanks. Those are free ends. We will connect them in next slides. First, let's talk about pipe flanges, because we will use flanges to connect ends with the tank nozzles. A pipe flange connects piping and its component in a piping system by the use of bolted connection, threaded or welding, and using gaskets. There are different types of flanges, and some are, as example, weld neck, slip-on, blind, socket weld, and threaded. There are different classifications of flanges based on pressure and temperature in material, which we call flange rating. ASME D16.5 is the most common standard used for flange manufacturing. I have made a separate video about flanges as well. If you want to know more about flanges, and you can have a look, and the link is coming at the top right side of this video as well. Now let's use flanges in our example and see how our piping system look like now. We have used two flanges in this example and shown in the circle. So tank 1 and tank 2, tank 2 and tank 3 have been connected with the help of flanges. In the third tank, which is a tank 1, and in a red circle, nozzle is connected with the pipe with the help of welding. So you can see now we have no loose end in the piping system. We have used all basic piping components. But there are many parts of the successful, safe, economical, and reliable practical piping system still missing, which we need to cover in next slides as well. So far, if you have any question, query, or feedback, do let me know, and you can share in the description of this video or other contact details which I have shared earlier. And just as a reminder, I can share in the next slide as well. So these are my details, my LinkedIn page, my WhatsApp number, and again this YouTube channel. Now I will talk about first valves, because we have to use valves in our example as well. So let's talk about first what are the valves. Basically there are two broad types of valves: manual valves and control valves. Valves are used to have control of fluid flow, to close, open, or to regulate flow. In this slide I will talk about manual valves. As name suggests, these valves are operated physically. There are different types of valves like gate valve, ball valve, check valve, butterfly, globe, needle valve, etc. There are different construction materials like carbon steel, cast iron, stainless steel. They have different flange rating as well. They have a multiple parts like body, trim, seat, and the valve ends as well. So we need to know all these aspects of valves, especially whenever we will select valve and we will go for procurement. Now in this slide I will talk about control valves. Control valves are used to control fluid with the help of signal from a controller or actuator. These valves are used to control the temperature, pressure, liquid level of the fluid. These valves have actuators which are run by electrically, pneumatically, or could be hydraulically. Common types are globe valve, ball valve, and like diaphragm valves. I have made a full video about valves as well. If you want to know about more about valves, you can watch that video. The link of this video is coming to the top right side of this video. Now let's use valves in our example and see how our piping system look like. You can see here we have used two manual valves. These valves can be used to control the fluid. Next thing which we will add here in this example of piping system is a filter or strainer. Let's talk about first what is a strainer, and then we will use that in our example. So basically strainer is a small accessory or component that allows to remove and trap any harmful substances. Strainers are used to remove any contamination or debris from the fluid which otherwise can damage the equipment like pumps or compressor. There are different types of strainers like Y type strainer, basket type strainer. Some are temporary strainers as well, in which we use like when we first start the plant and during commissioning. Most common standard use for strainer design is ASME 16.34 or sometimes ASME section 8 as well. They have different materials, but commonly stainless steel, carbon steel, and for mesh we use normally aluminium. Now let's use strainer in our piping design example and see how it look like. Now you can see here we have used one strainer which is a basket type. This will help to remove any unwanted particle to go to tank 3. Now we will add more elements which are also really important. So in next slides we will use expansion joint, and this should give some flexibility to our piping system. First, let's talk about what is a expansion joint. We use expansion joints as a part of our strategy to give flexibility to our piping system. We don't use expansion joint quite often as they are weak joints and they are prone to leakages. But if we have to accommodate piping stresses, displacement, we provide expansion joints as well. The material can be metallic, non-metallic, depending upon the requirements. Common types are below or tie rod type, and their manufacturing design standard commonly is a ASME section 8. Now let's use expansion joint in our example and see how our piping system look like. You can see here we have used one expansion joint which is a bellow type. This will give flexibility to our piping, especially will manage load on tank nozzle. Now we will add some piping instruments to know about piping fluid inside the pipe. First, let's talk about what are piping instruments. When some fluid is flowing in a pipe, we need to know about some parameters including pressure, temperature of the fluid. To get that information, we need to install some elements which we call instruments. There are different types of instruments including sensors, alarms, indicators, regulators, transmitter, pressure gauges, and temperature indicators. Now let's use them in our example. You can see here we have used pressure gauge, flow meter in this example. This will give us control to know different parameter of fluid inside the piping, and accordingly we can calibrate process conditions to meet our project objectives. Now we will add some piping supports. This will give safety and reliability to our piping system. First, before using them, let's talk about it and try to understand what are piping supports. We need different types of supports to give reliability to our piping systems due to different reasons. They are like for sustain or gravity case, to give constraint for load and displacement for seismic and wind case, to manage pipe span, and it could be to manage pipe thermal displacement. Common types are arrest or V-type support, guides, line stops, anchors, pipe hangers, clamps, and pipe shoe. Now let's use some of the supports to our example and see how our piping system look like. You can see here we have used some of the piping supports. We have used pipe hanger, pipe shoe, and dummy leg at elbow. These have given strength, constraints, and flexibility to our piping system. After this piping layout, we need to perform stress analysis, as I explained earlier in this video. Right. Now, when we talk about piping design and engineering, we need to think about all aspects of piping system, not only design or engineering, but also about the inspection, asset integrity, maintenance, and other aspects as well. Because either that piping system is designed for 20 years, 25 years, so it should be good for that particular period. And integrity requirements and common other inspection operation problems are really important to consider as well. There could be like how piping can be saved or prevent from corrosion and erosion. What are common damage mechanism, and what material we should select to cover those damages, and what is the type of the fluid, and it could be like the environmental impacts as well. So if it's a coastal area or the harsh environment, so that should also consider in the piping design. So our design should be compatible for maintenance and routine inspection and operation requirements. Piping should be saved from vibration and water hammer like issues as well. Piping should be well placed to allow operation supports activities. There should be enough accessibility for the people, equipments, and like the crane and other supports for the personnel. Right, piping course is almost over. I have covered all the aspects of piping briefly. Again, that is just like a tip of the iceberg, because piping is a quite in-depth field and discipline, and it requires in details knowledge, and especially when you use that knowledge in any particular project, so it has to be compatible with the requirements, and every project is different. So we have to use best practices, standards, codes, clients' requirements, and to make sure all the aspects whatever we propose in the piping system, starting from piping component, all the component mostly I have covered in this course, so those has to be compatible with the code standards, and again, after layout we have to make sure materials and stress analysis requirements are also met. I believe this has covered all the piping aspects, but if you want to learn more about any area, I have these 6 courses as well, which you should get if you want to enhance knowledge and confidence about piping. Let's talk about briefly about these courses, which I think we should cover all the piping basically in more details as well. I have already talked about the questions, you can get that one as well, and but if you are interested to expand your knowledge any particular area of piping, so these courses might be helpful. So first one is a engineering fundamental of piping and pipelines. So basically this course covers all aspects of piping broadly. You can say whatever you have watched in this video, this course will talk about in more details of all these aspects, and with more practical examples as well. This is very useful if you want to know the overall piping basically. Next is a piping stress analysis using Streezer 2. This course is a very important and could be helpful for stress analysis if you are interested about that, and if you want to know about more like what are the fundamentals and the basis of stress analysis with the reference of the codes and their inputs, outputs, how to do stress analysis, use example, concept, principles. So that course may be helpful. Next is a piping stress analysis, but using software AutoPipe. So basically, this course is also covers most of the aspects as the previous stress analysis course, but the tool has been used different, which is the AutoPipe. Next course is understanding and application of process piping code. As I said, SMB 31.3 is the most commonly used course. So that course is talk about all aspects of SMB 31.3, starting from the design, starting from about the different components requirements and the material, and talk about the fluid types, and then the entity requirement and the testing and hydrostatic and all those aspects. What is the code? So basically more interpretation of the code, more understanding of the codes with the references, as I said, design, engineering, component fabrication, construction, and inspection. So that could be course helpful if you want to enhance your knowledge particular about that code. Next course is a piping layout. As I said, I have just touch base just briefly what should be considered in the piping design and layout, but there is a lot of things when you do piping design layout up, like for example, if you have to do piping design around pumps or around the columns, there are so many aspects you need to consider, and this course will include aspects of design, engineering, and best practices and standard codes references. And it could be like piping rack, heat exchangers, and as I said, so there are best practices like how about the like the reducers and fittings and the supports. What should be the support and what should be the supports? We know there are so many fittings and the pipe supports, and what support is more preferable at what location. So there is so much thinking and best practices which we need to know, and this course will be helpful if you are looking for that information. Last course is about piping materials. So as I touched base earlier in this course about piping material, so this course will go in more details about what are the applicable standards, codes, and about piping components, their materials, their procurement requirements. This was useful if you want to improve your knowledge about piping material. If you are interested about any course, do get in touch with me, and I have already shared my contact details. As I mentioned earlier about this my book, which is a first edition 200 questions with answers, and this could give you a good in-depth knowledge about piping. It's really easy to understand as it is in the form of questions, and those questions are from practical experiences people have talked about, and you will come across those in your routine projects, and rather than just reading boring like long books of any standard or code, it's really a great idea to grasp all the piping concepts if real and practical questions are answers. So if you're interested to get that book, so do let me know. And in the last, here are my contact details as well. So my LinkedIn page, EKT Engineering Consultants, my WhatsApp number, and YouTube channel. So that was all about piping course. There was a huge demand about that course, and it took me a long time to produce that course, but finally we are here, and I hope you have liked this course. And as I said, this is just starting point, and whatever your background, and you could be like engineer, design, you could be in operation, maintenance, inspection, could be any discipline. I believe this course is enough to answer a lot of questions, and do let me know your thoughts, your feedback, and also let me know about this course, and also let me know what you want to want me to produce in next slides. Until my next video, take care and bye.